Hey everyone, welcome to the stream. It's Alfred.
Submarine.
And this is episode 134. So in this episode, Submarine is going to be showing you how to program your Matrix Voice ESP32 in order to have it as like an audio streamer for Snips. So you could basically, Submarine will explain.
Yeah, so technically what's happening is your ESP32 Matrix Voice, you're programming it, and you're having it publish the audio that it's receiving to an MQTT like topic, and then the Snips audio server, which is running on a Pi somewhere else connected to the same Wi-Fi, is subscribing to that and getting all that data. And so if you like tell Snips like make sure to listen to this device, this like external device for the hot word, as it's listening to the stream of audio, if it hears the hot word, it will then send like a ping back to the ESP32 Matrix Voice in it, and then that's when the LEDs turn green, and it like continues to hear what you're saying.
Okay, so it's basically you can have standalone Matrix Voice ESP32 as like a satellite, like anywhere you want, and it's just constantly sending the audio to like a Raspberry Pi or like your computer, right?
Exactly.
And then it's just simpler. You could make them like a light switch that's even thinner. So cool.
The form factor of the standalone voice is amazing. So small. But I want to say before we start, this actually, look, we didn't come up with this. One of our community members, his name is Paul Romkis. He goes by Rumkabouter on our community if you want to look him up. He came up with the guide. And you know it's pretty crazy. Like there's a lot of work that went into it, and you know we'll see how it works today. So really
and then
exciting.
That was amazing. Like this is just a community post that we've now like just made into a guide. So that's great. We love it.
Yeah. All right. So let's get right to it. I'm gonna switch over to the screen with us. So you should be able to see us here. Okay. Cool. So right here is the guide, Matrix Voice Satellites. I should refresh this because I did change the name to ESP32 Matrix Voice Satellites. But anyway, I guess I didn't update yet. Okay, so going down, and so required hardware. You need a Raspberry Pi 3 or 3B Plus right now because Snips doesn't have support for Buster yet. So we're going to use Raspbian Stretch for this. And obviously Matrix Voice ESP32 connected to it, power supply. That's pretty much all we need. Obviously micro SD card, all that stuff. I don't know why I'm going over this. We normally never do.
But now you know.
Yeah, but now you know. Okay, so let's get started. So first we're going to follow the Platform I/O guide that Boris did last week, because a lot of it will be the same. It's just a different code base. So going over here, the Platform I/O guide, it's linked right here, so I just already had it open, but it's just this link right here.
And if you don't know what it is, it's basically just a way to be able to easily program your Matrix Voice via like VS Code. So instead of doing it like through Arduino, which can take a little bit of time, especially the setup, you could just do it way more seamlessly this way.
Yeah, so Visual Studio Code, as we always say, is a really nice editor, and we really like using it. So this extension, one of our coworkers, Antonio, came up with how to integrate it with Visual Studio Code through Platform I/O. So the Raspberry Pi setup, let's do that first. So obviously you all have to let it know where the Matrix packages are located and everything. I've already done this, but I'm gonna go through it really quickly for you to see. So you do that, and then you update and upgrade. Also already done this, but I can copy paste it, but you know how it goes. So and then same thing, so the Matrix Creator init package initializes like the FPGA, ESP32, all those initialization scripts. I'm not gonna go upgrade, it's already upgraded. Okay, cool. So then copy paste that, and then you reboot. Cool. So that's already done, so I'm not gonna do that. But you would need to do that when you're starting from scratch. So sudo voice ESP32 enable, this line basically kind of readies the ESP32 to be flashed. So if it's running anything, it'll kind of pause. And then this line right here resets the memory of the ESP32 so that if anything was on there, it'll now be erased. And so that's happening right there. Setting up Visual Studio Code in the Platform I/O extension. this was one this has been explained in the other live stream, but you basically install GitHub. You can install Visual Studio Code with the link here, Platform IO with the link here, and it's a really easy setup. It takes like 5 minutes to do. So, that should be pretty easy. So now that we're at this point where we're going to clone the repo, I'm not going to clone this one, but instead I will clone the repo of today's guide. So this repo will be cloned on your personal computer. So this is my Pi, so I'm not going to do it in here. I'll be doing it on the personal computer in a folder I've called Livestream, so I'm just going to clone it. And then once I've done that, I want to open the project in Platform IO. So opening Visual Studio Code, and take a second, there it is. So once Visual Studio Code opens, once you have Platform IO already installed on here, it'll automatically open another tab saying Platform IO Home. It's actually checking for that right now, and there it is. So in the Home directory of Platform IO, you can go to Open Project, and then for me, this is stored in Desktop, Livestream, right here. So if I do that and then scroll down a little bit, you can see it says Open Matrix Voice ESP32 MQTT Audio Streamer. It's a really long name, but we forked it from ROM's repo, so it didn't change the name there. Okay, so then if you want to open it in the side tab where you can see all the files, just do Open Folder, navigate to the folder, so Live Stream, Audio Streamer, Open. So that first Open Project part basically let Platform IO know where it's located. So even if you use a different IDE to edit the code, Platform IO will still be able to access and compile it, which is really nice. So you can actually use a different IDE as well, but we really like Visual Studio Code. So after you're on Platform IO, you're going to edit like a couple of things in the platform.ini file. And this is honestly the only thing you need to edit if you're just deploying one ESP32 satellite voice. If you're doing multiple, you'll need to edit the code a little bit, and I'll show you in a bit what part of the code you'll need to edit. So because this is sending data over Wi-Fi, audio data over Wi-Fi, you'll need to put your Wi-Fi SSID and password. So you just say like my Wi-Fi or whatever your Wi-Fi SSID is, my password, whatever your Wi-Fi password is. So the site ID, this is by default Matrix Voice. You can leave it, you can change it, whatever, but this is important because whatever your site ID is what we're going to later use in the Snips configuration files for it to know what kind of ID to listen to for data. And the IP address is also something you have to change, the MQTT IP and the MQTT host. So the variables you change here actually get pulled into the main code. That's why we're changing them here. So my IP is 122 today, and then I'm going to change it here as well. So for the host and the IP, you have to change them both. And this IP address will be the IP of the Pi that you will use as your server computer. So I will actually end up using this same Pi as my server after I flash the ESP32 Matrix Voice. So you change the IP right there, and then you save it. So when you save it, you'll see that little like dot next to platform.ini disappears for Visual Studio Code. So that's really nice. So going back to the guide, so this is what all of these steps are. It's how to open the folder and what to change. So going back to this guide, this specifically tells you so this guide is very similar to the Platform IO guide, so that's why we link it there and just tell you the little differences so that it's not like a huge repetitive guide. So once you've opened it in Platform IO, you change the Wi-Fi credentials, change the IP and host IP. We just went over that. And then to deploy the audio streamer, we're basically going to use the same concept as this one, which is right here. Okay, here. Initial build and deploy. Okay, so to compile the code, click on the button with the check mark. So that is right here. It's a small button, but if you click it, you'll see this terminal that pops up on Platform IO. And I'm going to make it bigger so you can see. And it just goes through everything, compiles, it takes like not that long, just a couple minutes. It'll say success in a bit, and then it's done. So these are just warnings, so don't worry about the yellow stuff. Should take like a minute, maybe less. Usually it's really quick. It feels everything feels longer during a live stream. Like when I was doing it earlier, I was like, oh yeah, this took no time. And now that I'm sitting here like and it's live, I'm like, oh, this feels so long.
Yeah. That's time just increases in a live stream.
Yeah, hopefully it's not the same from the viewer's point.
Yeah, well, the viewer can just skip ahead, at least if they're watching it later on.
True.
If you're watching it with us, then, well, you're in it with us.
Yes, and we appreciate that you're here.
Yes.
Thank you very much for lending us your Friday evening, if you're in the U.S. East Coast, that is.
Yeah,
Sorry.
Yeah. Well, most of
Friday.
The world, Friday evening, if not Saturday morning.
True. Okay, so success. Yay, that took less than a minute. It tells you, yay. Okay, so that's it. That's compilation. And now to deploy it, you go to your terminal. You go into your MQTT audio streamer folder. So here, let me show you where the instructions are. So you just CD into the folder, OTA folder, and then the script is called install.sh, and that's written over here. Well, it's not written over here, haha. But basically, you go into the OTA folder, and that's where it is. So I've to hide the password of our actual Wi-Fi, I've actually have another MQTT audio streamer cloned somewhere. So I'm going to CD into it the way you would have to, and then go into the OTA folder because that's where the deploy bash script is. And then you do ls, you'll see install.sh. So this is what's going to install everything, the compiled, whatever just got compiled. Firmware.bin is actually what is made, or the file that is made after you compile with Platform IO. So that's what we're flashing to the ESP32. And then bootloader.bin and partitions OTA.bin, these files were pre-made, like we made them, and they basically are the bootloader and partitions of like what part of the ESP32 memory does what, and you don't need to touch that. And if you want to make your own, there are ways to do that, but it's just not really necessary. You just need to edit the firmware that you want, like of the audio streamer. So we do //install.sh, and then the IP of your Pi, 192.168.1.122 for me. And then Raspberry, which I was like, oh my god, I said my password out loud, but it's okay.
The same thing.
For a second, I got freaked out. Okay, so I'm holding this up because as soon as this is done, you should see the Matrix Voice LEDs go red at first because it's not connected to Wi-Fi, and then instantly blue, yay. Okay, well, it's fine. It's blue, which means it has just connected to our Wi-Fi. Yes. Okay, so now, and this white thing, don't worry about it. It's when it becomes this like red-white color when because it's always streaming audio to, you know, the server, and the server hasn't really been configured yet. This is a Raspberry Pi. We're going to do that part now. So it goes white when the audio that it's streaming hasn't completely gone through. So it should still work when it's. So I took it off, and then I'm going
the Pi
to
first.
Yes, unplugged it first. I'm being safe today.
Yeah.
I'm always safe.
Yeah.
And then plug in the ESP32 standalone, red at first, then blue, connected to Wi-Fi. Good. So I can put this away for now. And then connecting the standalone Pi to power, so we can configure this as our server. Okay. So now that we have that, I will SSH back into the Pi. But okay, I'll just do a new tab. let's see, SSH pi at 192.168.1.122. Okay, cool. So we did install.sh, your pi's IP here. We just did that part. And so the rest of the platform IO guide that Boris went over last week goes over like deploying through the command line if you want to do that. I won't show you that today. You can check out that live stream and this guide to see how to do that. And then this guide is also nice because it goes over how to read the UART for the ESP32 if you're trying to debug. So I'd recommend looking through all of this guide, even though right now we're done with the Platform IO Visual Studio Code Setup guide. So going back to the Matrix Voice Satellite Streamer guide, so now we're going to set up the Raspberry Pi server. So all of these little like comments here are just like stuff that you should know. So OTA, which is over-the-air programming, is enabled on this, but because this code is so heavy, it only works half the time. So I would still recommend putting it on the Pi when you're reflashing it, because it's like constantly sending stuff over Wi-Fi, and OTA is over Wi-Fi, so you could see how that could be a problem. The source code, I want to quickly talk about that. If you want to edit the code, it's in src matrix voice audio server.cpp. So on GitHub, I'm at that location right now. There's a lot of things going on in this code. If you want a more commented version, at the end of this guide, our team member Alexis actually put a more commented version of the code here if you're not sure what everything is doing. So that can be helpful for if you want to know what certain parts are doing and you're not entirely sure. So this is the code you would edit. And if you have questions about it, please post on our community. We have actually set up 2 audio servers or audio satellites talking to a server before. It's really fun. Yeah. And you can do it from different rooms. It doesn't matter where they are as long as they're connected to the same Wi-Fi. So it is possible. If you have questions about that, please ask on the community. Okay, so going back to this. So now we will set up the Raspberry Pi server. Okay, so first you'll need to set up Snips. So there are 2 ways you can do this. You might have a Matrix Voice satellite and also a Raspberry Pi server with a Matrix device on it. So that, like, I'm not going to assume that most people have 2 Matrix devices, so I'm going to do the version where you have just a Raspberry Pi as a server and then a remote satellite. But if you want to do the one where you can also talk to the Pi, because there's a voice or creator on it, as well as have a satellite, there's directions for that too. So we're going to do without Matrix device setup. So right here we have, okay, yeah, this is not updated. That's why I was like, because yeah, we updated this guide right before publishing. I'm gonna open a new window and open it again, because I was like noticing things that I changed already that hasn't showed up here for some reason. Very odd. But anyway, same guide. It has been updated, so going back. All right.
So this is what you guys would be seeing.
This is what you guys will see. Yes. The one before had some extra steps that Carlos, one of our team members, optimized to make it look much nicer and shorter. So yeah, so this is what you'll see. If you want the Pi and the Matrix device, then you follow the whole Snips Setup guide, but because we're only doing the Pi as a server, we're going to follow steps 2 and 3 of the setup guide. So go in there. Step 2 is installing SAM CLI tool on your personal computer. So clear. We don't have to do that because SAM is already installed, but it's only one line. You just copy paste that. And then you connect SAM to the specific Raspberry Pi that you're working on. So I'm going to do SAM connect. Oops.
And in case you guys are wondering what SAM is or what Snips is, you can go to our previous video of setting up Snips on a Matrix device where we explain all these things, what SAM is, how to use the Snips console, and we'll include a link to that live stream down in the description below.
Right, exactly. Good. Good idea. Okay, connect. So press enter. So this is so that this tool knows which Pi it's supposed to look out for. So you just have to press enter for these. You don't even have to type anything.
Unless you've changed like your Pi's username and password.
Yes,
but this will like it already knows the default one. So if you still have the defaults, you're good.
So then at the end you type SAM init, and what that does is it installs all of the Snips packages on your Raspberry Pi, on the Raspberry Pi whose IP address you put in there. So that's really nice. So right now it's installing all the Snips packages. I've actually already done this, so I don't know if it'll actually take a few minutes. But yeah, it looks pretty quick. It usually takes a little bit. And then the next, so I'm just going to move on, keep talking while it does its thing.
Grab a cup of tea and relax.
Yeah, that's really funny. Okay, so going back. So we've followed steps 2 and 3. We're done with this guide, the Snips Setup guide. Okay, so at this point, we would edit the snips.toml configuration file, right? But what I found is at this point, it sometimes already works. That's why we're going to over-engineer it and put some extra stuff anyway, but we're going to check if it works right now so that you can already see. So right here, I'm going to do sam watch. Okay, there it is. It's watching. Hey, Snips. What's the weather in Miami? Okay, so as you can see, I'm going to make this bigger. So when you do Hey Snips, it detects it on the site matrix voice. That's because in our code we set the site ID was matrix voice. So you see why that's important. And then when I said what's the weather in Miami, this is where it detected it. So what Sam Watch does is it listens to the MQTT messages. And then it responded to me as well, which is really nice. So we're going to over-engineer this and put extra stuff in there, which it works with as well, because there have been times where it has not worked out of the box.
Just like as a fallback.
Just as a fallback, yeah. So the fallback is editing some files in the, well, a file in your Raspberry Pi. So I'm going to SSH back into the Raspberry Pi server. So that is SSH, well, maybe I already have it. Yeah, cool. Put the password in, and great. So now, since Snips is already on here, there should be a file called snips.toml, and that's like a configuration file with a lot of different things you can do for Snips. So we're going to go all the way down to a part that's snips-hot word, because we want it to be able to detect the Snips hot word from... Oh, I already did this, because I tried this guide already, I forgot. But anyway, in reality, it's going to look like this by default. It's going to look like this. And what you're going to want to do, well, actually, there's going to be a plus sign there. So all of these pound signs means that they're commented, so it's not actually doing anything. So what we're going to do is we're going to replace this line with this one right here. So what this does is it tells the hot word to listen to 2 different site IDs. The default, which means if you had a matrix device on your Pi, it would listen. That would be the default. So it would listen to the default, and it would listen to the matrix voice site ID right here. But since we're not, we don't have a matrix device or any other microphone for that matter on this Pi server, we're going to get rid of the default part, and that's written in the guide right below where it defines what the values are. So default is the site ID of the matrix device sitting on your Pi, and then you should remove it if the server doesn't have a microphone. So you would do that, and then Control XY to save, and then just to... Okay, so cool. And so just to make sure that this goes through, I would recommend restarting the Snips audio server, and you can do that through your personal computer through SAM. So you do SAM service restart, and I'll include that in the guide, I forgot to do that earlier, and then you do Snips audio server, and that would restart the Snips audio server on your Pi. Just do SAM watch again, and we go again. Hey Snips, what's the weather in Miami?
Nice.
And that's basically it. Here's the restart. It did include it. It just got moved around by the beautifier. I was like, I forgot. I forgot to put it in. Okay, cool. So this is a really cool project because you could have multiple, like we said, right, of these like Snips satellites all over your house, talking to one Pi server, doing so many different types of things, like lights, maybe like Zigbee, Z-Wave stuff at some point.
Yeah,
like,
there's a lot of things, and it's so small. You know, like we had made another guide on Hackster of a light switch, like controlled with a Matrix voice, but it had a Pi. So like the 3D printable case that we designed for it, it was like, you know, an inch thick. So now that we have this, we'll like redo that guide and make it even better.
Yeah. So quick thing that's really cool. This does output audio. So the audio is sometimes buggy, which is why like it's not front and center. Like, oh my god, it like outputs audio. It's really cool, but it is a bit buggy. But I will show you because it is very cool.
Yeah, and the buggy audio is just like a little software thing that we have to fix.
Yeah, so that will be improved.
Yes.
Yes. So right now, I just connected it to the speaker, as you can see. You can see. Okay, so we say, "Hey Snips." Whoops. What's the weather in Miami?
You asked for the weather in Miami.
That's coming from here. That's coming from the ESP32.
Woo.
That's pretty crazy.
Yeah.
That was actually like, other than the
that was a little weird.
Other than the static, that happens sometimes, I've noticed. I don't know why. Yeah. Other than the static, which happens occasionally, it's still pretty good.
Yeah.
Like, pretty good audio.
Yeah. And we have the speaker at like full blast too, so that's how we got startled.
Yeah.
But yeah, it's pretty good. Awesome.
Yeah, that's all. So I guess like I wanted to show it on the bigger screen too, like with the bigger camera, so we could have like
why not?
Thumbnail.
Cool. Thinking of the thumbnail
ahead.
You're watching us.
So I'm gonna show you all what this looks like on the table. Let's see. Okay, so moving it to the table.
Here, take away the wire.
Okay, so standalone matrix voice, speaker right here, and we're gonna say, "Hey Snips, what's the weather in LA?" Whoa. Sorry if that burst your eardrums.
Sorry.
Okay, but we have a thumbnail now.
Okay.
Alright, so let's move it back up to us so we can close out. Alright.
Okay, cool. Awesome. One thing I just thought of, and just for people like listening in earlier, the SAM, does it come with the demo installed, the weather demo?
No. Okay, so it does not come with the weather demo installed. Okay, going back to computer really quick. That's a good point.
Yeah. So if you were wondering earlier why it was not working, if you had just installed SAM for the first time, like we already have the SAM weather demo installed. And so that's why.
Thank you.
No
yes,
worries.
I forgot about that. So in the wrapping up section, because things got moved around, I forgot like where things were. Okay, so you do SAM install. So use the Snips demo to test your setup. Basically, you can use any any Snips assistant you want. Like if you made a Snips assistant on the console and you are deploying that, it'll still hear the Matrix voice audio. So if you do "Hey Snips," like, and you have a custom thing going like, "What's 2 times 4?" It'll still work. So this is just the demo's just
a demo.
A demo, yeah. And it's just a fake weather demo.
Yeah.
So when you do SAM install demo, it installs like a fake weather demo. This actually takes a while. And that's when, after that, you can do SAM watch and see all the logs and everything.
Yeah.
So I guess I'll switch back to the to the screen.
So just a little thing.
Yeah, definitely a good point. I forgot about that. Okay, cool. So... All right.
Awesome. Well, that's really cool. I'm really excited to go updating the light switch guide with that. Maybe this weekend I'll play with that.
That would be so fun.
Cool. So that's that. If you guys have any questions, post on the comments on Hackster, or even better, post on our community.matrix.one. I'm thinking announcements.
Yes. So if you have an idea for the Snips contest, there are 2 days left to apply. And look at this. this is something you could use.
Yeah, ideas.
Ideas. Yeah, this is really cool, and I really hope we get some like contest submissions that use this concept of standalone, like Snips satellites, maybe multiple. That would be really cool. Would love to see projects like that. And the contest goes for like 2 more months now, so
hardware. So the time period to apply in order to get free hardware ends in 2 days. So all you have to do is like write up what your idea is, and then I guess on Monday we'll be saying who the winners are. So early next week. Yeah. We'll be saying who the winners are. We're giving away 20 devices, whether that be creators, voices, whatever fits best for those 20 projects. So apply, and hopefully we'll see your submissions in the next 2 months. Besides that, I think that's it, right?
Yeah, that's all.
Okay, awesome. Well, thank you guys for watching. This has been episode 134, and we'll see you guys later. Bye.
Bye.